What is feature engineering and why does it matter? Algorithms learn from data, but feature engineering tells the data what to say. Feature engineering is the process of creating, selecting, or transforming variables to improve model performance. It is where domain knowledge meets data science. Whether it's creating interaction terms, binding values, or encoding time based features, it can make or break a model. I have had projects where switching from raw timestamps to day of week boosted model performance by over 15%. The algorithm was the same, the features changed the game. So, this is considered as one of the most important steps in data science projects and AI projects. It will definitely improve the performance of any machine learning models. What is the difference between batch and online learning and machine learning? Batch learning is like writing a book. Online learning is like writing a tweet thread one post at a time. Batch learning trains the model on the entire data set at once, while online learning updates the model continuously as new data comes in. Online learning is ideal for streaming data or environments where the data changes frequently, like stock market prices or real time recommendations. I use batch learning for historical analysis, but online learning was critical when building a prototype for real time ad bidding. The key characteristics of batch learning are data processing, model update, resource intensive, and predictive performance. The key characteristics of online learning are data processing, model update, resource efficient, and adaptive performance. How do you evaluate a classification model? Accuracy is just the tip of the iceberg. Real evaluation dives deeper. I use a combination of metrics depending on the problem. Accuracy, precision, recall, F1 score, ROC, AUC, and confusion matrix. For imbalanced data sets, accuracy can be misleading. So really move on F1 score and ROC, AUC curve. In a healthcare classification task, I prioritize recall to catch as many at-risk patients as possible while monitoring precision to avoid false alarms. What is regularization in machine learning? Regularization is like a leash for your model. It stops it from chasing noise. Regularization adds a penalty to the loss function to prevent overfitting. L1 regularization or lasso regression can shrink some weights to zero, helping with feature selection. L2 ridge regression spreads the penalty across all feature, keeping weight small but not zero. I often use regularization when working with models like logistic regression or even XGBoost, especially on high dimensional data like text or bioinformatics. What is the difference between precision and recall? Precision asks how often are you right. Recall asks how many did you catch. Precision is the ratio of true positives to all predicted positives. It tells you how many of your positive predictions were correct. Recall is the ratio of true positives to all actual positives. It tells you how well you identified all relevant cases. In fraud detection, recall is often more important. You'd rather catch all frauds even if some liquid transactions get flagged. In contrast, precision matters more in spam detection, where false alarms annoy users. Here's today's pro tip. When you answer technical question, don't just define terms, connect them to real problems. Anyone can say what recall or regularization is. But if you explain when it matters and why it changes outcomes, you show real expertise. And don't underestimate feature engineering. It's often more powerful than tuning hyperparameters. A good feature set can turn a basic model into top performer. So, practice not just solving problems, but explaining why your solution works. It's more important than anything else.